Hi, I'm Gareth Branwyn, Make's editorial director, and today we're going to show you 3 breadboard-based experiments for motor controllers using the ubiquitous 555 timer chip. Using little more than the 555, some common components, and a few logic chips, we're going to show you how to control a DC motor, a servo motor, and a stepper motor. By doing these experiments, you're going to learn the basics of these motor types and how to make them go. Let's get started. Here's Tyler in the lab.
A robot is a computer that can dance, or at least move around. That motivation usually comes courtesy of something called a motor driver or a motor controller. This is a board of specialized circuitry, usually with its own onboard microcontroller that tells a motor how to behave. For instance, in what direction to move and at what speed. All motors have a controller of some kind, from a simple on-off switch to a very sophisticated controller that allow for steering, speed, torque adjustments, and all sorts of other useful control features. In robots and other hobby electronics applications, there are 3 main types of motors used, and each type requires a different form of control. These 3 types are DC motor, servo motor, and stepper motor. Usually, each control type requires a different collection of parts and a different logic or microcontroller chips. But we thought it'd be fun to see how far we could get with the fewest, simplest parts. After doing some research on the internet and some experimenting on his workbench, Make Projects contributor Steve Hobley figured out how to control all 3 types with the lowly 555 timer chip. And you can too. Here are the parts you are going to need. This list assumes you are going to build one driver at a time on the same breadboard and reuse the same parts for each build. The most common type of driver for a DC motor is called an H-bridge because of the way the circuit layout resembles the letter H. We're building an H-bridge circuit using 2 555 timer chips. The 555 is one of the most common IC chips in the world, and we use them at the heart of all 3 of our motor drivers. We think this is pretty nifty. This circuit uses little more than 2 555s on a breadboard, a DC motor, some jumper wires, and a potentiometer to control the motor's direction. Consult the illustrations and photos on Make Projects, and then you can wire up the breadboard at your own pace. When all the hookups are completed, apply 5 volts to the power rails of your breadboard. To power all 3 of these circuits, you'll need to deliver voltages between 5 to 12 volts. We recommend either using a benchtop power supply or a variable voltage power supply. With proper power delivered to the board and the pot connected, you should see the motor move in the direction you twist the pot. You can make a flag out of tape to put on your motor to better see its movements. Servo motors are frequently the muscle behind robots and in other applications like RC vehicles. They allow you to direct the motor's shaft and what it's attached to a precise location. In our experiment, using a very clever little hack of a 555, we'll get the servo to move where we want it, where it would normally take much more sophisticated electronics. Make the connection and consult the illos and photos on Make Projects, and do the connections at your own pace. When all the wiring is in order, apply 5 to 6 volts to the power rails of your breadboard, and your servo should turn as you turn the pot. In practice, this servo controller can be a little jittery. That's because the servo is usually looking for wider pulses, and we're serving it with very short spiky pulses to create a wider pulse. We found that the better quality the servo motor, the more effective it is at filtering out the instability. Like the name implies, stepper motors step through their motions, moving along toothed steps inside the motors. This allows for another way of providing precision control, like a servo motor, without the need for an internal gearbox. Your computer printer and similar devices employ steppers. Like the servo, they usually require some finicky electronics to control them, but we're going to do it with a single 555, a couple logic chips, and some transistors. As in the other 2 projects, consult the online diagrams, photos, and docs for complete part details and hookup instructions. This is our most complicated build, so take your time and make sure you have everything hooked up correctly. Finally, Hook the motor coils up to the transistors on the breadboard as shown in the illustration and connect the common stepper motor connection to the 12 volts. When the transistors are activated, the current will flow from the common line through the motor coil into the ground via the transistor. Now, as you turn the potentiometer, the stepper should follow suit. We hope you had fun experimenting with these breadboard motor controllers. You should now have a greater understanding of these important motor types and what's involved in controlling them. Now that you have the power, get out there and set your projects in motion.